Assalamualaikum and good day to both of our esteemed panel, Datem Dr. Fazilah binti Salim and Madam Rohaina binti Jaafar. My name is Mohamad Arif AlHafiz bin Zaidi and I am from 4BEEY. My bachelor degree project title is The Development of Rainwater and Domestic Water Supply Integration for Energy Utilization. First and foremost, let me start my presentation with the project introduction. Nowadays, people have realized the concern of renewable energy for daily life. Installing a renewable energy is one of the options that can be made to produce energy even on small scale. Next, renewable energy is becoming the fastest growing energy type as countries switch from fossil fuels to various renewable sources. The advantages of getting electricity from natural sources like sun, wind and water are threefold. Besides, a pico-hydro is the hydroelectricity generation method with the maximum electric output of 5 kW. Pico-hydro technology has been recently improved and evolved, making it an easily available and cost-effective source of energy even in remote locations around the world. So, basically, I have two objectives of the project. First is to develop a rainwater and domestic water supply integration for energy utilization, and second is to investigate the performance of our system. Next is the methodology of my project. In this topic, it consists of three parts. It is flowchart, water flow meter design, and charge controller circuit of my project. First is the flowchart of my project. The project started when domestic water from the main meter flow through the turbines that are located at any water tap at your house. The best is to choose the tap that is constantly used daily. For the rainwater, the pipeline usually is connected to outlet that barely use. Both of the turbines are connected to charge controller. Both turbines need to be function well in order to produce the utmost output from the system. The rate of water flow through the turbine is important to make sure you know how much the output produced. Next is the design of the water flow meter using Arduino. The water flow meter uses Arduino in order to display the reading of the water flow. The reading is in liter per minute unit, and the LCD also displays the total water flow through the water flow in liter. This helps to track down how much liter of water flow through the system. The idea of using Arduino is in the future, IoT can be installed to monitor the water flow through by smartphone. The flow rate of the water is very important because of some flow rate produce very small output and no reading available on the multimeter when be checked. Last but not least is my project overall circuit. For the project circuit, the charge controller act as the main component in the project. Both of the turbines are connected in series to utilize the maximum output from both of the turbines. The charge controller is connected to either battery or load. The charge controller minimum input is 12 volt and up to 24 volt, and the output for the USB port is 5 volt and 2 amp, which is very suitable for phone charging. For the rated current is around 10 amp for the charge and discharge. The water flow that use Arduino are placed at the outlet of the water, which is flowed before the turbine. The water flow sensor can detect the flow rate in between 1 to 30 liter per minute, which is around 60 to 1080 liter per hour, which is very useful and convenient. Next is the result analysis I've gained from my project is, as you can see, there are three tables and the reading is for the flow rate, voltage, current and power. All data are the average result that have been collected in the first few months. Firstly, the data below shows the higher the flow rate, the higher the voltage produced by the turbines. The rate of flows is controlled by stock and inspection have been done to make sure there is no leakage on the stock. The current produced by the turbine are very low, and the formula to calculate the power is P equal to IV. The result can be seen on table 1 and table 2. So, for the table 1 is result of the domestic water turbine. The maximum voltage it can produce is 11.38 volt, which is quite high considering its size. The voltage produced is mainly depends on the flow rate. The flow rate for domestic water turbine is higher than the rainwater because of the water pressure in the domestic water flow are higher. The power that produced is 1.01 watt, that shows that the turbine is very capable. And for the table 2, is the result for the rainwater turbines. The turbine is connected to the rainwater tank that are located in the ceiling. The result obtained is quite different from the domestic water turbine, and the maximum output is just 7.78 volt, and the current produced is very low. The power that can be get from the rainwater turbine is only 0.08 watt. On the other hand, there are also the result for in the table 3 that are very different from table 1 and table 2. This is because the result is from the combination of the turbines that are connected to charge controller. The voltage from both turbines is connected in series to increase the total voltage output to power up the charge controller. The power that being produced will increase because of the both turbines are combined. The voltage output is 17.21 and at the highest flow rate, and it produces 1.7 watt, which is higher than result from table 1 and table 2. So as conclusion that can be made, the development of rainwater and domestic water supply integration for energy utilization will surely open people's eyes to how important it is to generate your own electricity, that also will help you to preserve nature for longer term. There are also some future work recommendation that can be done in the project. Number 1 is installing an inverter for the project could be a big turning point for the system, because the DC output will be converted to AC output directly and connected to AC load for daily household usage. Next is putting an IoT system on the project to monitor the system anywhere, anytime, only by using smartphone. Last but not least is to replace the DC generator with an AC generator. This may rise the project cost, but AC generator can be used directly to household, and also the maintenance for AC generator is quite easier.
So today I will demonstrate to how do I take my data for my project. So as you can see, this is my domestic water turbine. It's connected to multimeter, and here is, as you can see, is the flow water sensor meter. So if I want to check the reading, okay, first I will turn on the pump. I pull the top up until it's full gas, and then I turn on the flow rate sensor. So the sensor is turned on, as you can see, and the water flow is 4.35. So next I want to measure the voltage. So as you can see, with the flow rate, you can get 10.65 volts from the domestic water turbine. Okay, so now let me test the output for the rainwater turbine. So the rainwater turbine is actually connected to the rainwater pipeline. There are rainwater tank in the ceiling. So let us test what is the flow rate first. So when I open it at a full, the flow rate is 4.65. So what is the voltage output? So the voltage output is 7.32 volts. Okay, so now I have connected both of my turbine in series to a charge controller. So as you can see, the charge controller is turned on because there is a connection in battery. So the charge controller input is 12 volts. So let me turn on one turbine first. Okay. So if I switch on one turbine and I check the voltage reading. So the voltage reading is only 10. So the charge controller will not charge up the battery. So what I have to do is I need to turn on both of the turbine at their highest flow rate. So as you can see, when I turn on both turbine at their highest flow rate, the voltage is 12.29, and the charge controller is charged. So I can charge the battery and at the same time the battery can supply the load. So both turbine need to be series in order to turn on the charge controller and charge the battery.
So that's bring us to of my presentation. Thank you for sparing your time to watch and listen to my presentation. I'd like to summarize by saying that renewable energy is the key for a better life in the future. So that's all from me. Thank you.